Okay, so today is quite important subject, really important. So as you remember, we try to observe development of software engineering, and now we come to this huge topic which called object-oriented programming. Object-oriented programming, OOP. This is absolute crucial topic. I could compare this as the most important topic in case you want to become software engineer. So this concept and all which is related to object-oriented programming just absolute crucial and absolute must for your daily software engineering activities. So of course we have different paradigms in programming. Object-oriented programming is one of the paradigms. We mentioned structural programming, it is another paradigm, and so on. But in most cases, in most common general cases, while we're developing front-end systems, back-end, mobile applications, and so on, we use object-oriented programming just everywhere. So that's why it is so important to understand, to dig into this subject, and I'm really highly recommend you to be very attentive and to search by yourself, not just during this class, but also jump into this subject to understand this subject. All right. So I would like to come back with you to the idea of black box. Do you remember this idea we talked with you? That software is some black box, and we have some understandable interface how to use this black box, and we have some results from this black box. So we compared this black box with method, functions. You remember that we have our method, we have signature. Signature of the method. Do you remember what is that? Signature of the method.
First line of the method, basically.
Kind of just first line of declaration of the method. In that first line, we know everything about how to deal with this function from the outer world. We know that, okay, we could call this function with this name, we will put this kind of parameters into this function, and we could have this kind of result from this function. Everything inside the function, we call, by the way, how we call that inside the function? Body of the function, body of the method. Everything inside we could consider as a black box, some complex algorithms inside of that. But when we use this function in the outer world, we are not required to know exactly how this algorithm works. We just should know how this function in general works, what interface, what signature of this function, what results this function has. And then we could use that. And in such a way, we could build complex logic. Because inside our function, we could call another function, another method, and another method, and maybe in this method we call another method. And in such a way, we decompose very complex activity through breaking that into different methods. We understand that, right? Like we decompose some complex task. Okay, that's right, that's very good. And overall idea of software engineering, of programming, it is how to make hard tasks, how to make it more easy for us to deal, how to reduce complexity. I want you also remember this phrase, reduce complexity, because we can't just keep in our mind all these parts of algorithm. We want to reduce that complexity so we could deal with that. But we have a problem with this. Because function, it is just one call, it is one activity or one action. We want to do this action, so we run this function. But in real world, that entities, that objects in real world, they have more than one action. So for example, let for us, we want to present in our program such entity as a student. So student could have some activity, some action. For example, send assignment. Send assignment.
Excuse me, we don't see you. We don't see you.
Oh, what? Oh, okay. I need to share. Okay, sorry guys who are online. Can you see now?
Yeah.
So,
Yes.
excellent. So, our student has some action. He could send assignment. So, for this function, like send assignment, we could create this black box, and we could have some signature of this black box, and we know how to use that. But could you give me more examples about student? What another activity student could have? Another action.
A lot, for example, no. Visit the campus, for example.
Okay. Yeah, visit, let's say visit class. Okay?
Check his grades.
Huh? Check his grades. Okay. Check grades. And so on and so forth. So we have a bunch of activities which are related to our entity which we call student, whom we call student. So the student could have different activities. So of course we could create our structural program as before at this moment, and we just could have many methods. This method, and this method. But could you tell me what this method will use? Do you see any common things that all these methods should use to perform algorithm, to perform some activities inside that method? What do you think? What this method will use, which is in common for all of them? Student. Okay, what exactly about student? What do you think?
Name.
Okay, so some name. What else?
Faculty.
Okay, faculty maybe not about student, but okay, program, for example, on which student is assigned. What else?
Classes, right, probably.
Huh?
Classes, probably. Like,
His classes, yeah? Okay, his classes.
grades, basically.
Again, his grades, his maybe some ID number, email, for example, also, which is so important, and so on and so forth. All of that related to student, correct? That means that in many of these methods, we should get some part of this data. Do you agree? And that means that maybe we should pass that data in that functions as the parameters. But in any case, we will work with this data inside body of these black boxes, these functions, and these algorithms could influence this data, could change this data. For example, visit or assign to the class, and we will add one more class to our student classes. Or check grades, or maybe send assignment, or get assignment grade. And some of that method could change this data. Do you agree? Yeah? That means, and now remember your methods which you created before at this moment. You had different methods, but you work with specific data inside this method, and that's it. You didn't use kind of additional data somewhere outside this method. You didn't work with the same. However, it is possible. Could you remember that scanner? Scanner which we declared at the top of our class. Do you remember that? And all of our methods just take this scanner, use this scanner outside kind of inside the methods, but we use this global variable, let's say. So we had this example. Now, just imagine that we have some complex data about the students. We have different methods. Most of that methods work with this data, change this data, and at the end of the day, you have this program, you have different variables, kind of global, you have different methods, all of them somehow use this variable, then maybe you have one student in your program, then you have second student in your program, then you have third student in your program. And somehow you should represent all the different students using some versions of these variables and use by all these methods. So could you imagine how hard to deal with all this complex stuff? You understand that it is, or that is first student, then or second, on and so on and so forth, and we have really messy code then. So that's why in object-oriented programming, creating black box, we're not using just actions to hide, to encapsulate this hard logic inside this black box. But also we add attributes to our black box. So finally, at the end of the day, we have attributes like properties, name, surname, ID, email, all of that is attributes of some entity. Okay? But also we add what is which we already know. It is activity or actions. So we also have some actions. So let one more time, let me summarize what we have. To represent some real object from real world, for example, student or customer or product in internet shop, or message in Messenger, or something, or button in my interface, I have this some object, and this object could have properties and actions or behavior. Every object has some properties and has some behavior, some actions. This is the main idea of object-oriented programming. That we split our hard domain, we break up our complex tasks, not only to functions, not only to methods, but we break our hard task into objects. Object have attributes, and some activities or behavior. And you know, it becomes much more easy to think about our systems in such a way and to create hard, complex behavior of our computer systems. So again, you have some interface in your messenger. You have a field where you type your message. You have send button. You have properties of this chat. You have button how to go back and so on. All of that are actually objects, and that objects have some behavior, have some activity, have some methods. So, in case of syntax, what that means? Let me give you an example which we already discussed regarding student. So we have student object, marker. student object or student class. I will describe these differences between class and object. But student has attribute name, which is string, last name or surname, which is also string. What else? For example, enrollment year. Okay. Enrollment year. What data type for that? Integer. Okay, so we have some attributes, program. Let it be string, and so on. Then this is attributes. Then we could have some methods. So let me add method get information. Method. Get information method will return string, which contains all the information about this student. So we encapsulate that inside this object. Okay, our student of course could have something more, but maybe at this point it is kind of hard to propose you some additional methods. But the idea is that we have object has properties, object has methods. And this is what we call object or class. We should discuss differences between these two
Can I have a question?
ideas. Yes.
Do we need to write methods inside of the body of object, or can we get them outside?
Yeah, exactly. We should have all of that inside our black box. So outer world will use this method, and this method will use this particular attributes. And we could create one student, then we create another student, and another student, but all this method of each of that students will use this particular data which is related to this specific student. And we will have no any mess in our program because we have separated black boxes which work with its own properties. You could imagine that like your desktop, for example, which could be messy, or when you make some like how to say that ubорка, sorting, okay, on your desktop, and you could put, oh, this should be here. This is my pen and pencils. This is my papers. So this is my I don't know, some electronic stuff, and you put everything on their place. The same with objects. We combine everything related just to this object in one syntax structure inside our class, and we know definitely that we will have no any mess that, or this method goes for another properties and we don't know what happened in our program. Okay. So next, let me propose you this another idea which you should understand. Okay, for example, when architect create building, he prepare kind of blueprint of that building, right? So he have work with papers and some computer programs, and he prepared, okay, that this kind of building should be built. Then builders take this blueprint and actually build the real building, right? You understand this? Pretty easy, I believe, for all of you. So, I really would like you to remember that class, this is our blueprint of future object which should be created. Class is a blueprint for object. So we create this sketch of our future object, and then somewhere we create actually version of this sketch in real world. So actually you have class here. Finally, we come to this point where we discuss what the class means. But before this moment, we never created any objects. Yes, we had some this class which was just boilerplate code for us. But now let's create object or another class. So in the same file, let me create class student. And this is because I already have another. So actually, yeah, it is interesting problem here. So because I already played a little bit with that, and I have another student class, so I can have two classes with the same name, two blueprints with the same name. But in this case, it is very convenient, and I would ask you to use this. Create a new package, and inside the package you have your separated area, and you could use any names you would like to have. So I create package. Where is that? Student library. Let it be. So here I will delete that. And I move to this student library package, and here I create another class. Let it be again main, just to show you, add to Git repository, just to show you that I could replicate and have the same kind of main class, but still have any problems, because I'm located in another package. That's why I could have another classes with the same name. Okay, so I have main class. I will use this main method to run this particular class, but let's come back to student. So I will use this the same file, but actually I could just create another file, and in most programs that would be more convenient, but here just to simplify stuff. Student. So now I created new blueprint. This is the sketch of future object. Now, let me have that properties which I proposed before, earlier. Public string name and public string surname. Okay, let it be. Now I have this future blueprint, and now I would like to have not just class, but rather object of this class. So again, class is a sketch, is a blueprint, but building, to have a building, I should create this object from mentioned class. How to do that? So I declare variable student, name it somehow, and use new. You already know this operator new. New, it is to build, to create real object, not just sketch. And I name that particular class which I want to use. So we created object. Now I could do something with this object. For example, how to use these properties now, how to assign some value to that properties. So I use the name of the variable std dot, this is operator named accessor. How to access our black box? We use just dot.
dot name, for example, or any other part of my class or my object I could use here. And put some value inside that. Same way, I could use surname okay.
Can you repeat what does STD mean?
Yeah, std means name of variable of type student. One more. std, you already know the syntax. First, it is data type of the variable, correct? For example, integer, string, array, or student. std, just the name of the variable, okay? But student is a data type for this variable, right? Do you understand that? I know that it is hard to understand when you first meet this object-oriented stuff. So that's why I would like to make this emphasis to that. So again, what is class actually? Class is data type. Just custom data type. Abstract data type which you created yourself. If integer, boolean, double, all of that created by Java developers, student created by you. This is it. This is your data type which you just created. So class is data type and object is what? If class is data type, then object what?
Variable.
What is object?
Variable.
Variable. Please remember that. Variable. This is the relation between these two concepts. Object, this is just variable of newly created data type, which you created by yourself. And class or object is variable of that data type. Student, let's create another student. Okay, new student, std name, okay, John, std second surname, Johnson. So now in our program we have two objects or two variables of type students, two students with different attributes. And I could output that parts of that classes. So for example, std2 surname. I could output that. Let me run. So I just output Johnson, surname of my second student. Okay, this is the example where we created objects. We created first class, then we created objects. But now, tell me please, does our object has any behavior or just attributes? Just attributes. So it is not such interesting. We said that the main power of object-oriented programming that we could combine attributes and behavior in one object and consider our system in such a way. So let's create some method. Wait, let it be. So again, this is now. Pay attention. No any static here. No static here. Because now we work with real object-oriented programming and we don't use static at this moment. Get or print, let it be print, okay. Print information. Public void print information. So here I could format and somehow output information about my student. So of course I would like to access my attributes inside this method. So I could use name, and Java understands that I mean attribute of this class. Then I could add some separator and surname. Okay, actually I could use just one line for that, but for you to make it more visual, I use 3 lines for this one system out println call. So please pay attention. We have in our print info method, we access students' attributes name and surname, and just output that. So let me use this. I will delete this line, and now let me use std print info for first student and print info for second student. Okay, run. This is it. And this is the most powerful thing, that we have different objects, but we do not duplicate our code. We use the same pattern, how to output information about our student. We implemented this here. We don't need to pass any parameters here in print info because it is part of our object. And we already have all of that parameters encapsulated or hidden in this object or enclosed in this object. And we just easily work with the same attributes and create some behavior around that attributes. So for example, use this method. Do you have questions about that? Do you understand that?
What if we use instead of void something with return?
Yeah, good question. Let's do it. Actually, that's really nice to have. For example, let us have not just print info, but get info. And return value will be of type string. And we have this get info method. And we will not print anything into console, but we will return just a string. Name, class, surname. Okay, so this is the example of another method which already has return value. So in this case, I could use system out println, then access my student and print get info, because get info gives me string and I could do something with that string. Okay, let's run this code, and we have information about first student being printed in console by system out println, but this information we get from get info. By the way, when I push command or control in Windows and click, you see that pointer, and I come to declaration of this method. Okay, it is declaration of variable, actually, std2. Okay, but I would like to have, of course, a jump to declaration, or maybe I jumped, but because of my screen zoomed. So this is jump to declaration of get info when I click. So just use that. It is very good behavior of IntelliJ IDEA. Okay, now I could, by the way, reorganize my print info. Why not use already defined method get info? So do not duplicate yourself, and just output this. So for example, I could easily access another method inside method. So could you please pay attention? We have print info method of student class, but inside this method we call another method of our student class, because get info already format information about my student, and I just output it here. Why it is important? For example, this what we just changed in our class. For example, later you add program. You develop your program and you add some new attribute to your student. So in case you have this output, which should like duplicated code. So I just output it here, and I get info. In this method, I create string which represent my student. But now I add one more attribute, program, and in my program, in my main method for student number 1, I add program equals BC, and for student number 2, I also add program equals bachelor data science. Yeah. So now to output all the information, I should refactor or change my getInfo method, and also I should change printInfo method. So I should add program be like this, program, and access program field of my class. But also I need to change getInfo method and do actually the same, which is not good because I'm repeating myself. That's why we try to have just one occurrence of specific algorithms in our classes or in our programs in general. So now you see this code is duplicated here. So that's why I propose to delete printInfo specific code and just use more advanced version when we are not repeat ourselves, but we just call this black box which is already implemented in another method. Like, yeah. So this is it. This is just a little bit of software engineering principles, like dry, do not repeat yourself. This is one of the principles of software engineering. Okay. At the end, let's run this code and see new version of our information, Petro-Petrenko program BDS. And we, of course, could think, oh, I would like to add some new formatting. For example, I would like to have this mark here and so on and so forth. So we could just make small changes, but change overall behavior of our class student. And we don't need to repeat ourselves and so on and so forth. Yeah, good question actually. So, you know, most of our software systems and programs started from one method. This method called main in many programming languages. So here we have this starting point of our program, main method. So this is just syntax. But because of Java is fully object-oriented language, they encapsulated this main method inside the class, which is kind of, you know, boilerplate, or it is just, you know, play around. Because actually we don't need to run just to have one starting point to create all this class, you know. In C++, for example, you just have main and that's it. But this is syntax of Java, and Java fully object-oriented, so everything in Java is objects in classes. So that's why we have this syntax here. So when we have this specific signature public static void main, we could tell Java that you should start from this point. But inside this main, we already have all the power and authority to decide which classes, which objects to create. And that's why we have here student object or class we want to create, and so on and so forth. So this is actually how it works.
So if there will be no like public static void main signature, then the program will just not work.
Yeah,
Right?
exactly.
Okay.
Yeah, exactly.
We can change the name.
Main?
Yes.
You can change main for starting point. You could actually change class name of starting kind of class, but this is requirement. How Java could understand, or it is starting point, I should run this function at the very beginning. Yeah, so it is required.
Yeah, so in our main we also have a class and an object, right?
Exactly. We have class, but we have no object. And it is interesting stuff starting here, which is connected to static keyword. Let's move on. Let's go. So of course I would like to come to this explanation of static, but let me concentrate your attention first on another concept. So constructor. It is another very important method in our object, which is constructor. Syntactically, constructor is a method with the same name as our class. So what name of our class? Student. So if we create method, but regarding signature, we have no this return value. We just create this signature, public, and then student. And this is it. So you see student here, and just the same method without return value data type. So let me just do something here, and I will create some output in console. For example, create student object. And I would like you to pay attention. So I added constructor. So when I run my program now, remember I have two objects, std and std2. I run my program, and what do I see? I see one line, create student object, and another line, create student object. But nobody called this method twice or even once. Nobody called student method. What that mean? Now please pay attention to our syntax here. It looks like method. Agree? Student and brackets here. So actually when we have this line, when we create object, constructor being called automatically by our system. So we created new object in this line, and we create new object in this line. That means that our constructor was called twice, in this line and in this line. So if you output something here, you will see that student like being created, this create student object will be output, then another output, and only after that correspondingly this another constructor. Yeah, question.
So it means that in our class student we created a method that is called student.
That is called automatically when student object been created. A little bit longer sentence, but you should actually understand that. Inside our class student,
Yeah.
we have method student, which actually we even in these diagrams, which you see, by the way, it is real software engineering diagram, like class diagram in UML notation. So when we have constructor, we could even like mention it in this diagram like constructor, not like student. So because it is specific service method. So when from our class we create object, every time it is kind of sort of initialization method. This method being created. Why do we need this method? So let me give you an example and you will understand more why it is so important to have constructor. First of all, when we create in this line, okay, let me make it a little bit smaller. So in this line, when we create an STD object, what do you think? Before we run these lines, what contents of name?
Nothing.
Nothing, null, actually. We didn't initialize this variable. And you know it is not so good. There is impossible to have student, for example, without name. Yeah. So every student has a name. So that's why, for example, we could assign default values in constructor. So I could use name. For example, no name student. And surname also not assigned, for example. And program, maybe program I would like to have, you know, some default program. Most of our students, for example, this or another program. So for example, I could have something here, some values. Let be this extended software engineering, for example. Okay. So now when I output my STD in this line, STD name, before I assign another name like Petro here, what will I have?
No name.
Exactly. I will just have this no name. No name. Because my constructor being called, and I initialized my members of my class. By the way, please remember one more definition. This is methods of my class. This is attributes or fields of my class. All together we call members of my class or my object members. So I could play with this in constructor. I could assign some attributes. Okay? So that's why please understand what constructor means. To give you more interesting examples, so I could create this default student, but also I could simplify my life as a programmer. I could create even another constructor. Oh my, it is something interesting. I have the same method with the same name, but with another parameters. And what else? Year, integer. Do I have actually year? I have no year in this class. Okay, let it be just program Okay, I don't want to use program here. For example, only name and surname. Okay, so what do I have? I have two constructors. First constructor without parameters and second constructor with parameters. I didn't do anything with these parameters at this moment, but you understand what I want to do. But let me show how to call another constructor. So I will command this line and create my student with another constructor. And for example, what problem? Public, forgot or what? Yeah. No? Public student. Okay. Seems correct. And now I even command these lines because I already don't need that lines. Okay, pay attention. I created in the same way I created student, and I put my default values here in this like a parameters. Yeah, that's interesting that all of you, many of you just type in. That's an interesting way to make lectures. But so, pay attention please. I pass parameters here, and these parameters should go somewhere. At this moment, I just get that parameters and do nothing with them. But I want you to know that I could create my student with constructor using some of my constructors. I could have many constructors. By the way, it is called overloading when I have the same method with different parameters. Okay, but tell me please, what actually I should do in this method, in the body of this new constructor? What do you think? No, not
Assign like name equals name.
name equals name. Yeah, Ivan.
Like we should not simplify, but like say that we have this name in the object. We should assign it to the new name that the user uses.
Okay. Yeah.
We need to initialize these variables to this.
Yeah. You, all of you are correct. So we should put name. We have some problem here. So it is also interesting point, and you should pay attention to that. But actually, we want to put value from here to our field. Correct? Correct. So here we have misconception. We want to assign, as Masha said, name to name, but we can do that because the problem is when I declare my parameter with this name, then for this function, when I use name, then Java will understand that this name corresponds to this parameter, not to my field. But I actually want to access my field. So in classes, I have this trick. I use this dot name equals name. So this, it is another concept that you should understand. Inside my class, if I use this keyword, that means that I'm referencing what? Myself. I referencing my object. So I referencing this new created std, and inside this std I have this dot access name, yeah, and that's why here we have no problem. So Java knows that this name corresponds to field and name corresponds to parameter. What do you think? What another way to solve this problem with naming?
Just rename attribute into brackets.
yeah, just rename this stuff. For example, name parameter, and in this case, I could use name, and you see it is Violet. IntelliJ IDEA helps you to understand that Violet means that it is member of our class. And name parameter, and this is really parameter. But of course, it is more beautiful to have the same naming. It is more understandable, so that's why we could use this way of solving this problem. And surname equals surname, right? Okay. I have some questions in the chat. We can see the screen. Okay, they solved. Messages. Right. Okay. So this is interesting. So you see that I don't need these two lines. I pass name Petro here, and I could output to be sure that actually it works. So let me run and see the results. Not no name here, now it is Petro here, because I already initialized this name variable. Okay? You understand what constructors are, okay? Super. So next, you understand what is this, and let me very quickly show you what the difference between private and public, because everywhere here I use public members, but my members could be also private. So for example, let me add new member in my class, private. Enrollment year or intake year. Integer. Okay. And what that mean? That I have private member of my class. That mean that outside my class, if I try to access intake year, equals you see it is impossible because it is private. You can't access private variables. It is closed from the outer world. So if I make now it is public, then I will not have any errors. Now it becomes possible to access this from the outer world. But I would like to have private variable. Okay, now, what do you think? Why should we have these private members of our class and public members of our class? What do you think?
So people can't reach private.
People can't reach some private stuff in our class.
We basically need to protect our information. For example, if we have a database for a bank or something, we need to protect the data. And just to...
Yeah, to protect our information, to close it inside our class. Yeah? Okay, any other thoughts? Yeah, cool.
To hide the implementation from the programmer that will work with this class, to hide all the details.
To hide
that is
details.
inside.
Okay.
So he can shoot himself in the foot, obviously.
Absolutely. Every answer is correct. So, this is one of very important principles of software engineering, which is information hiding. We have, again, black box. And this black box is quite complicated. It uses different parameters, properties, and so on. It is like electricity, yeah? You have this interface, how to connect with very complicated stuff inside that socket. Electricity, physics, laws of physics, some automatic equipment, some you know, all that constructions. Imagine if you want to use any device, you should just take these two, remind me how to call that.
Plugs. Plugs.
Yeah, plugs, okay, провода.
Ah, okay.
Wires.
Wires.
Yeah, exactly. So imagine that you need to take these wires and connect by yourself and be very isolated and with all. It's just really hard to work with this with such system. That's why engineers created this interface to this black box. This is our black box. This is our interface to this black box. This interface is public. Everybody could use it. But all inside this black box is private. You could not use all of that to plug something, right? So the same thing with our classes. Our classes could be very complicated inside, and it will be not useful when you use some of your class and you should know everything. Okay, it is ground, it is plus, it is minus, and oh, I should remember everything. No, you have just very plain, easy public interface. Public, you have these public methods or public fields. But except of that, you have in your class another logic. You decide to hide this information. When you hide information, you make your system more easy to deal with. You reduce complexity, remember that. So you broke your task into easy part and you separate you from the outer world and decide just this task here. And give some interface into outer world, this one. And hide all this information. This is the idea of private and public. So any of your member could be public or private. Public, it is for outer world. Private, it is hidden for your algorithms inside your black box. Understand the idea? Okay, we have this. We almost done, and that's why we have one more concept for you to understand. It is getter and setter. As I said, all this private public stuff, we very often do this. We have some inner variable and we want to give interface to outer world how to set and get that variable. Actually, I could generate that, hopefully. Refactor.
It's in the generate.
To the left right now.
Yeah, to the left a bit. It's not in the refactor. It's
Generate within.
Yeah.
Okay, generate getter and setter. Yeah, I want to generate for. Yeah, I should not show you that. You should be able to write it by yourself, of course. But it is such a boilerplate, easy code. I just want to. Yeah, so this is generated for me. Okay, I would like to put it a bit below. Right. So this is getter and this is setter. Getter to get my private variable to outer world, and setter to set my private variable. So to set, I should have parameter of integer of the same data type, and to just assign this to my variable. So please don't think about information hiding like to make every private stuff public through the getter and setter. This is not the idea of information hiding, but it is just such a concept when we want to provide access to some private field with getter and setter. So how to use getter and setter? Let me show you. We know that I can't do this, but what I actually can do, get, or not get, but set intake year. And here I put my value. Now it is possible to jump in my black box and to using proper interface and to put some specific data. Maybe inside this method I will make you know, some additional logic. For example, I will check, I will validate if intake year, my parameter less than 2022, then maybe some error. Oh, it's not possible, for example, because AUK started just first intake was last year.
But it will still accept this year.
Huh?
But it will still accept this year.
Yeah, this still accept, and I should actually make some, you know, maybe write some logic to return and so on. So why should I have this setter? Yeah, because in this setter I could have some validation, some business logic checks, and so on. So I will reduce errors in my class. That's why we could have setters and getters. This is the idea of setters and getters. Do you understand that? Do you have any questions? Okay. Okay. So actually this is it for this lecture. I have one challenge, one more last thought for you to explain static and instance. I could say it is a bit complicated at the moment, but I really recommend you to deal with this knowledge. So the essence is this. If you see, every method in my student class has no static keyword, right? I have no static here, print info, get info, or setter or getter. I don't have any static word. But, okay, not but what that mean? That means that every of that member is related to my actual object variable. But sometimes we could create interesting, very, very interesting stuff when we could have methods not of our object, but of our class. For example, I could have counter, and this counter will be static. If my, for example, member variable counter is static, that means that this variable related not to the object, but actually to the class. And it is something mind-blowing. It is hard to explain people, oh, you know, class is a blueprint, and this variable connected to blueprint. It is not possible to do anything with blueprints in real buildings. Yeah, but it is not construction, buildings, it is programming, so we have a bit another concepts. It is possible to have some static variables, static members for class. That means that we could use that static members without creating of new object. Exactly what you did with main method. In your class static main, you didn't create any object, but you use this method. It is possible because this method is static. Static method, that's why you could just run it. So if I create static method of my student, public static void count, let me call it. And I will, okay, not void, let it be integer. And I will return something, let it be 0 at the moment. So I have some method. It is static method. What that mean if this method is static? That means that without creation any object, I could come to just my class student and access count here without creating any objects. So So here stuff become a bit complicated, but still it is very useful template we could use. So for example, I would like to count every student I created in my program. So I could have private static variable, integer variable count, which is 0 at the very beginning. I could initialize this in this way. And every time I create a new object, I will increment my count. I could actually access static variable in instance, in object. So I did it for every of my constructors. I know when I create new object, constructor will be called. So this is it. And I will return this count here in my static context static method. So that's why I created few objects. And at the end of my program, I could output how many objects I created. So I call static member of my student class, not object, but class, and print count. And we see that I created 2 objects. How I calculated that? Because of static member count. With use of static method, I get this information. Yes, question.
So basically, we use static in order to use this variable in anywhere we want in the program. Is this what static
Yeah.
for?
Yeah, that's correct.
Okay.
And you know that static is a method of the class method, class member. And all that in other method are instance methods or instance variable, because instance is object, variable, already created, built, are this class static, we just call it class member of the class, not of object, not of exact instance, but it is overall class. Yeah, so this is quite also very interesting subject, which is, of course, we use because we have the static mind. That's why you should know what is that. So you could play with that and learn a bit more to have this full understanding of that. Right, okay, well done. Let me show your task and ask you to work with your tasks. And I allow you to work with pairs or by 3 of you to work with this task.